Okay, example number 3, vitamin D resistant rickets pedigree. So the first question once again says identify the inheritance pattern. Okay, so I'm just looking at, this is a lot to go with, which is actually kind of a good thing. So the first thing I do is I always look for parents that are the same. So they're either shaded in or unshaded. And I have that right here. I have 2 shaded in parents. So if this was recessive, then all of the offspring would have to be affected. So let's just, if it's autosomal recessive for sure, which is always what I look at first. So let's say that's, this is autosomal recessive. Okay, then every single one of these kids would have to have little a's and little a's, and they'd all have to be shaded in. So that tells me this is not recessive, it's dominant. Okay, now is it autosomal or X-linked? Okay, well, let's check for males. 1 male, 2, 3, 4 affected males. Females, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 to 9. That's more than double the amount of affected females. I'm thinking that this is X-linked dominant. So it's X-linked dominant. All right, if it's X-linked dominant, let's just do a quick allele legend here. We're talking about vitamin D resistant rickets. So rickets, I'll put that is the, you have rickets, and little r is your normal, and then Y just means that you're going to be a biological male. Perfect. Okay, so let's just do, before we even try to figure out those daughters and everything, well, actually, no, let's just go straight to that. Okay, calculate the probability that individuals 2, 4, and 2, 5 will have an affected daughter. Okay, well, 2, that's generation 2. So that's this generation 1, this is generation 2, this is generation 3, this is generation 4. Okay, so 2, 4. 2, 4, 2, 4, 1, 2, 3, 4. 2, 4 is this person because it goes 1, 2, 3, 4. And 2, 5 would be this guy right here. Alright. So what's the chances they will have a daughter? So it has to be a daughter and it's affected. Okay, so what would that even look like? That would be, an affected daughter would be, first of all, it's a circle, and it's affected, so it would be that. And because it is X-linked, she could have 2 possible genotypes, or it could be big A with a little a. Okay, let's figure this out. Okay, so this mother here is affected, so that means she has at least 1 big A. I'm not sure what the second one is. The father is not affected, so he has a little a, and then he has a Y because he's a male. Alright, so we have to look at their children. Okay, so the Y chromosome is always given from the father to the males. The males always get the Y chromosome. And the females will always get the father's X. And he only has that little a. So I think the females are going to tell us a story here. Because this one, I don't know, the males can too. That one's colored in. This one has to be a little a. So that little a had to come from mom, which means she is, there we go, X little a. Let's see if that works for the rest. Yeah, she gave a little a there. And here she gave a big A, which we do know she has a big A. She has big A. There we go. Okay, so now that we have their genotypes, we have to do a Punnett square because we want the probability that they can have an affected daughter. So now we have them right there. Okay, so this mother here has either an X big A or an X little a that she could give to her children, and the father, he has a little a or a Y. We're just doing a Punnett square here. Okay. This would be a female that's affected, female unaffected, male affected, male unaffected. And what are we looking for? An affected daughter. So an affected female, and that affected female would be there. So it looks like there's only a 1 out of 4 or a 25% chance of an affected daughter. Okay, so it's 25%. Okay. Next question. Now we got 3-1. I don't want to use that color. 3-1. Okay, 3-1. Well, I guess you're pink, buddy. I think he's okay with that. And 3-2. So they're having kids. They have 3 kids already. And what's the chances that they would have an affected child? So just affected can be male or female. So in this one, instead of just looking for a female, it could be that or that. That's what we're looking for. Okay. Well, we know it's possible to have affected female. I don't know about the son. Probably not. Okay, let's take a look. They're shaded in. So we know that, oops, this is X-linked. We know that she's got that. We know that he's got that. We know that he has a Y. And I'm not sure what her second X is. Let's take a look. Well, we know that the Y's are always given to the sons, and there's a son. There's a son. And this daughter here has to get a big A from dad. Dad always gives to the daughter there. Okay, the X. And if you have a big A, you have to be shaded in. But these ones who get their X from mom are not. She must be a hetero. Okay, so now we know that she gives it a little a. Okay, so now we know their genotypes. Now we do a Punnett square. You guessed it. So this one here, she's got a big A. She's got a little a. And this guy here has a big A or a Y. I love how my furnace is running right now. It sounds like somebody's urinating because of the humidifier. Okay. Alright. Alright. So we're looking for anybody who has a big A. Oh, look at that. You can get a son. So this one here, big A, and big A, and a big A. They can only have females that have big A's. That's because of the father. Alright, so it looks like it's most likely, it's actually quite rare to get these two. That's this one, 25% chance. They broke probability. So that's 3 out of 4 will be affected. And that's 3 out of 4 or 75%. Alright. So hopefully some of that made some sense.